And boom.
Thanks, Dean.
You bet. This is the Series 7 Guru, also known as Dean Tenney, coming to you from my studio in fabulous Las Vegas. Casey has been lucky enough. She better come out and see me in Vegas to win two coaching calls on Tuesday night in a row. Woohoo! So now she's collecting. And so we were talking about some of the things that she would have on a data dump sheet for her Series 65. And I was commenting on editorial decisions. And one of the things she had on there was the rule of 72. She had present value, future value. And I had said, hey, Casey, why don't we just stop right there and let's get ourselves a whiteboard and let me see if I can illustrate some of this to you. So mainly it's going to be inputs and outputs, not so much can you do the math. I had a guy, Casey, I charged $225 an hour for tutoring, and he was doing tutoring. He said, Dean, I'm not paying you $225 an hour to do math with me. He said, I'm a serious math geek. I can do any math. Give me any two numbers. I can solve for the third. And, good news, he passed. But when he called, to tell me he passed, he said, Dean, I got myself in a little hot water because it wasn't, can I do the math? Did I recognize the input and output, the information needed to do the math? He said, I was able to kind of make it up and figure it out, but I wish I would have paid a little more time to Casey, like your data dump sheet, and just being able to recognize inputs and outputs. So let's say I have a 50-year-old customer, and what I'm going to attempt to show you in this whiteboard is the concepts on your data dump sheet. I'm going to attempt to show you the idea of present value and future value. I'm going to attempt to show you an illustration of the internal rate of return. And I'm going to show you how to use the rule of 72, how that could be helpful. And now it's up to us as a test taker to recognize what the kind of question is. So I have a customer who's 50 years old, wants to retire when they're 70 years old. So I should immediately say, okay, I have a time horizon here question. So I should be able to recognize as a test taker that we're looking at a time horizon of 20 years. And boom, I'm going to put that there. And I'm going to put this here. Let's get a different color. Boom. And the customer says to me that he has $100,000 today. $100,000 today. And the customer tells me that when he retires, he want to have $400,000. And sometimes, sometimes it's just the fancy language that can get in the way of us answering a question. And what I mean by that is, if we think about it, we're trying to test in test terms. This is the present value. And this is the future value. And you can see in the context of, our practice that this could come up, that somebody could say something like that. So what we are trying to figure out is what would be the rate of return that we would need to turn 100,000 into 400,000. So we as a test taker have to say, well, damn, that Dean guy, he lied to me. He said I wasn't going to have to do any kind of present value, future value calculations. And yet here I'm staring at a question that looks very much like I'm going to have to do that. And if we take a look at the question, it has some symmetry to it. So we're on a 20-year financial journey to take 100 to 400. So halfway through that journey would be 10 years. So halfway through this journey is going to be 10 years. So I'm going to say, okay, well, let me see here. Boom, let's put our line there. If I could turn halfway through the journey, if I could turn that 100 grand into 200 grand, if I could double it, so let's put that there. This is going to be 10 years. 10 years is halfway through this. If I can turn that 100 grand into 200 grand and then double it again, I will arrive at my financial destination. So now it's time. I told you I'm going to try and accomplish quite a few things here on this whiteboard. The first thing we're going to do is we're going to recognize the rule of 72. The rule of 72 is kind of a nice cocktail party trick. And it tells me how long it will take to double money based on a percentage return, or how long it will take me to double money based on a time frame. And so here I need to double my money in 10 years, and then I need to double my money again. So what we're going to do is we're going to take 72 and we're going to divide by 10 years, because that's what the rule of 72 says, that if we do this, yeah, we should be able to come up with a rate of return that would turn this into that. So rule of 72 is what we're going to apply here. We're going to divide by 10 years. And we find out that that would mean we need 7.2% to double this money. And so here I'm using the rule of 72. So now I tell my customer, if we could get 7.2% on your $100,000, we would arrive at your financial destination, because we double it to 200 and then we double it again. And this is what we need to double. So that would be 7.2%. Now, how would this be phrased as a test question? A customer is 50 years old and has $100,000 to invest. The customer wants to retire at 70 years old with $400,000. What is the internal rate of return, or what is the rate of return necessary to turn $100,000 into $400,000? Now, I'm not suggesting that this might not be a bad idea. You might want to say, I think I'll just guess B, assign that to the universe, I'll make it up elsewhere. It might be something you decide to do, but you could say, oh, let me settle into this question. Let me kind of see if I can use my rule of 72. Now, let's say, as I told you, I was going to use this to illustrate, the most important thing is, again, inputs and outputs. Not can you do the math. But if I want to solve that future value, what are the inputs? I need present value. I need the rate of return, 7.2, and I need the time frame, compounding periods, 20 years. I'm not going to make you do the math. I'm not going to make you do math that would take the 100. Say our assumed rate of return, Casey, is 7.2. We have 20 years. What is the future value of $100,000 invested over 20 years at 7.2%? I'm not going to make you do the math. I am going to ask you to recognize, to do the math, we need the present value. We need the compounding periods, 20 years, and we need the rate of return. Now, another thing we might do, so that would be going from present value to future value. So let's put our little arrow there. Boom. I think that's what we're doing. We're going from present value to future value. The other thing we might do is, again, ask you inputs or outputs to go the other direction, right? To take the future value to the present value. And it's not so much can you do the math again. It's do you recognize the inputs, right? The inputs would be, again, we need to know the future value, 400,000 in this case. We need to know the number of compounding periods, 20 years. And we need to know the rate of return. In this example, 7.2. Not, can I give you the numbers and can you come up with 100 grand? Is you have a general understanding. Now, this number, the 7.2%, and I'm oversimplifying, which is always my job, is called the internal rate of return. 7.2 is what will take the 100 to 400, or 400 back to 100. That's called the internal rate of return. Sometimes when we test you on that, it would be about a bond, right? And I say you buy a bond for 90% of par, you're going to get back 1,000. And I tell you the yield to maturity is 8.5. I just made that up. But that 8.5 is the internal rate of return that takes the 900 to 1,000, right? So here I've covered 3 of the things on your data dump sheet as an overview. I've illustrated, I hope, how we could use rule of 72 to solve a question. I've illustrated this idea of present value and future value. And I've illustrated hopefully a little bit of what we call the internal rate of return. Now, we also have a concept whenever we're dealing with time value of money, we should always know that money today is worth more than money in the future, right? And so, the other way where this comes up in terms of, this is, by the way, called analytical methods or tools as this part of your exam, is where we do have a income stream involved, right? And I say, hey, Casey, you won the lottery. You can have $100,000 a year for 15 years, or you can have $1 million today, right? And then what we'd want to do is what we call discounted cash flow to kind of bring that, because you go, well, Dean, it's kind of an obvious thing. I would rather have $100,000 for 15 years because that's $1.5 million. I go, well, not really, Casey, because that 100,000 payment of 15 years from today isn't as worth as much as $100,000 this year. And some of the other categories in the test here would be discounted cash flow. But I think that's a nice overview, a little bit of what's on your sheet. So let me just stop our recording here. Again, if you would like to win a coaching call, join us Tuesday, 5 p.m. And we can't do this kind of stuff in the live stream, but we can certainly in a coaching call like this. Let me stop the recording. Boom, boom, boom. It looks like I didn't. Did I even not record it? Oh, that's sad. That was beautiful. I didn't record it, looks like, but oh well.
I did though.
Okay, well, if you can send that to me,
I can. I will.
Let's
And
see
then
if
you can
I don't
edit it,
pause
right?
recording. Yeah, I can't believe I did that whole thing. And oh well.
Yeah.
Anyway, back to your, no big deal. But back to your, can you put back up your data dump sheet so I can look at that?
Yes.
And now I want to tie that to what I just showed you to that.
Okay.
So I like it. So again, inputs and outputs. So here we are. I'm just going to get out my annotation tool. And here is my annotation tool. And let me just do that. So here is what I just kind of showed you on that little example I did.
Right.
And I also showed you this, right?
Right.
So we took if we wanted to do the math, we would take the future value, 400 grand, 1 minus 7.2%. And the end would be the number of compounding periods, 20 years. As we said, we're not going to make you do that.
Right. We're
just going to ask you to recognize it. And then I also showed you how to take the future value back to the present value. Right. And again, it's the input. So, we had 400,000 and we're trying to figure out what